Hi, you're welcome to this video on chemical bonding, and today we'll be looking generally at ionic bonding, covalent bonding, and metallic bonding, and to some extent intermolecular bonding. And by the end of this video, you should be able to look at a compound and tell what type of bonding holds its atoms together. So you see how there are only 26 different letters, but when these letters are put together in different forms, they can form over 1 billion words. In the same way, there are over 100 different elements on the periodic table, but when you put them together in different ways, they make up everything from the plants to this pyramid here to even us humans. And this can happen because these atoms are held together by what's called bonding. So, bonding is simply just an attraction between these atoms or just the glue that holds them together to form new things. As we've already mentioned, there are three main types of bonding. We have the ionic bonding, covalent bonding, and metallic bonding. But the type of bonding that forms between atoms within a compound depend on where they find themselves on the periodic table. And as we go on, you understand what this statement means. Right, on the periodic table, all the elements found on the left of the periodic table are called metals. And here they are in yellow, and the ones found on the right here in blue are called nonmetals. You see, they're not always going to be in blue and yellow, but if you imagine putting a staircase from boron down like so, now anything to the left of that will be your metals, and anything to the right of that will be nonmetals. So remember this statement from before that the type of bonding that exists in a compound depends on which part of the periodic table it comes from. Well, this is what I mean by that. For a compound that has a metal, like say sodium, and a non-metal all involved within it, then the glue or the bond that holds the two atoms together is called ionic bonding. So where there are metals and non-metals in a compound, like in this example, the type of bonding involved is ionic bonding, and the compounds are called ionic compounds. But where a nonmetal like carbon and another nonmetal like oxygen are involved in a compound, the two atoms are held together by covalent bonding. So the bond between two or more nonmetals, like in this example, is called covalent bonding, and the compounds are called covalent compounds. Finally, the atoms in this gold ring are held together by a type of bond called metallic bonding. So the force of attraction between a metal like a gold atom and another metal like another gold atom is called metallic bonding. Okay, to avoid any confusion, ionic bonding holds together metal atoms and non-metal atoms, whilst covalent bonding holds together two or more non-metal atoms, whilst metallic bonding holds together metals and metals. So by now, you should be able to look at a compound and decide whether it's ionic, covalent, or metallic. So pause the video and give it a go. And here are your answers. And as you can see, ionic bonding holds metal and non-metal atoms together, whilst covalent bonding holds two or more non-metal atoms together. And for metallic bonding, they hold metal atoms only together. Finally, ionic compounds exist as these large compounds called ionic lattices. And they are able to form these because they have repeating units of sodium ions, which are positive, surrounded by negatively charged chloride ions, and therefore they are able to form these large compounds. But for simple covalent molecules like these methane molecules, they cannot form these large clusters because they do not have charges. So a different kind of bonding needs to hold their molecules together. And that's called intermolecular bonding, where inter here simply means in between and molecular means molecule. So intermolecular bonding, it's simply the bonding that exists between molecules. All right, that's it for now. I hope it wasn't too bad. Thanks very much for watching, and please keep subscribing to our channel. Bye bye.